Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll discuss a new topic regarding the Pelton wheel turbine, or we can say the working principle of a Pelton turbine. So in our last lecture, we have seen different types of turbines are there, and in that we have discussed about the Pelton wheel also. So based on the previous lecture, I can say this Pelton wheel turbine is a kind of tangential impulse turbine. Okay, so this one we can say it is a kind of tangential flow impulse turbine. Tangential flow impulse turbine. Actually, as per the energy category, the turbines are two types. One is impulse turbine, another one is reaction turbine. And as per the flow direction, it is a four types. That is tangential, radial, axial, and mixed. So the Pelton turbine is coming under tangential flow. Okay, that means the direction of this flow is tangential, and it is coming under impulse turbine. Impulse turbine means only kinetic energy will be act on the inlet of the runner. So this is the diagram. You can see the same diagram we have used during the hydroelectric power plant discussions. So the turbine which is used in this, that is actually Pelton turbine. That's why the same diagram I have taken here. So this one already you have discussed in a previous lecture how it is working. So this is a dam. From this dam, the water is stored here, and the water will be flows through these penstocks or a long pipes, and it will be discharged here at the nozzle of this pipe. Okay, and here if you see the water which is coming out from the nozzle, it will strike this bucket or vane. Okay, tangential. Okay, tangential. That's why it is called tangential flow. Okay, and the energy which is striked here, that is only kinetic energy. That's why it is coming under impulse turbine. Okay, so this Pelton turbine we can say it is a tangential flow impulse turbine, and the water strikes the bucket along the tangent of the runner, and the energy available at the inlet of the turbine is only kinetic energy. You need to keep in mind, because of this impulse turbine we can say only kinetic energy is striking there. Then what about, you can ask, what about the pressure energy? Yeah, the pressure energy which is present here in this flow, during this flow, obviously in the if the liquid is present here, the fluid is present here, here we have the potential energy. Okay, here we are having potential energy, and when the liquid or fluid started flowing inside this, it will have kinetic energy as well as the pressure energy. Here potential energy as well as the pressure also will be there. Okay, and when the liquid started flowing inside this one, as I told you, that kinetic energy as well as the pressure energy both are there. But while it is coming out from this nozzle, this pressure energy converted to kinetic energy, and it is striking the vents here. Okay, and this is the pressure which is acting here, that is atmospheric pressure. Okay, so you can say the pressure at the inlet and outlet of the runner or outlet of the turbine is atmospheric. Okay, that's why there is no pressure difference at this point in the impulse turbine. But in the reaction turbine, there is a pressure difference is there at the inlet condition as well as the outlet condition. That's why it is called reaction pressure. Due to the reaction pressure name, the turbine is given reaction turbine. Okay, and this is another one point. And this turbine actually, it used to work for a high head. This is to work for high head, and for low discharge. Due to this high head, it will give a low discharge. And next, this turbine actually developed by a scientist called American scientist. His name is Lester Alan Pelton. According to his name, it was named as Pelton turbine. His name is Lester Alan Pelton. He is an American scientist, and based on his trade, this turbine was named. And near about like 1870 to 88, in this range of year, it was developed. Okay, and as I told you, this diagram was like this concept was used already in our hydroelectric power plant. Okay, and the water will be started flowing from here. So these things already we discussed. Now we'll see what are the components or what are the parts are used in the Pelton wheel turbine. So these are the basic or main parts, you can say. in the Pelton turbine. The first one is nozzle and flow regulating arrangements such as spear. Second one is runner, or we can say rotor with buckets. Third one is casing, and the fourth one is braking jet. So these are the different uh, you can say parts, or these are components which are used in the Pelton wheel turbine. The first one, as I told you, this is nozzle and flow regulating arrangement. Now this is the diagram what I have taken. See, here also you can see this is the nozzle part only, but along with this nozzle part, the flow arranging elements are there. So here it is the small diagram was taken. Now here you can see that through the pen stroke the water is coming out. So it's same also here. The half of this part was taken. So the flow of water direction is showing here. So in this part is nozzle here. Okay, this part is nozzle part, and exactly to the nozzle of the part here, okay, a spear is connected. A spear is connected to this one. Okay, and this spear will be regulated with the wheel, that is hand wheel, or it can be a governor can be fitted to this spear to operate this one. So that will be a different one. Either you can use a hand wheel of this, or we can say a governor is fitted to operate this one spear. And from here, the jet of water will be come out from here. Okay, this is about the nozzle and flow arrangement. What I told you, that flow regulating arrangement. So how it will work actually? So the amount of water, which can say the quantity of water which is striking the bucket here. You can see this is connected to the bucket. So the quantity of water which is striking the buckets or vanes. See, the name of this is, you can say vanes, or you can say this is buckets, or sometimes previously we have called it is a blade. Okay, so of this runner will be controlled by the spear. This will be controlled by the spear. So you can say it is a valve type. Okay, regulator type is there which will control. Okay, and the spear is it's how it is. You can see it is a conical. It is a conical needle type is there. You can see this is a needle type, conical needle type. Okay, as I told you, either you can operate this one by wheel, or you can say some automatically governor can be fitted to this one. So when the spear will be pushed in the forward direction, the flow will be it will be reduced, or you can say sometimes you can stop it here. And when you take this spear backward directions, so the full phase flow will be started flowing through the nozzle here. So forward direction and backward direction we need to do. Okay, so based on this movement of this spear, our flow rate will be increased and flow rate will be decreased, and that will be strike to this vanes, we can say. Okay, so this is all about the nozzle and about the spear, which is came under flow regulating arrangement. The second one is runner. That is runner, or we can say the rotor. Runner or rotor with buckets. With buckets. So this is the second part. This is the first part, and this is the second one. Okay, in the second one, if you see the diagram what I have taken here, a big shape of this diagram here, you can see this one. So these are the actually if you say this is our runner part is there. Okay, I can say this is the outer part and this is the inner part here. Actually this is runner part is there, or we can say runner is nothing but wheel also we can say, or we can say a rotor, that means which is supposed to run, or which is running at this point. Like here if you see this one, this part is our runner part or rotor part. Okay, now here you can see this these are the blades. These are the blades or buckets. You can see it's type a bucket type is there. So all these blades or buckets are fitted on this. You can see it is fitted with a nut and bolt. It is there. So it is fitting on the runner. So yeah, this is the runner with buckets which is fitted. You can say this part is there. This one. Okay, the runner part with buckets. Bucket in the sense, as I told you, the vanes. Okay, so this is a circular disc. We can say this is a circular disc, and the outer periphery of the circular disc, the number of buckets are fitted on that. And each buckets are equally spaced. You need to keep in mind, so all these buckets are fitted with equally spaced and fixed. Okay, and the shape of the bucket, if you see, okay, it is like a double hemispherical cup type. It is a double hemispherical cup type is there, or you can say a ball type is there. Double hemispherical cup. Okay, small things you need to remember. These are the shapes are there. Okay, if you see, this is the shape. These two are there. Two ball type is there in the middle. One line is there. Okay, and these two things, these two balls are separated. You can see this is one bucket, this is another one bucket, suppose. So each bucket is divided into two parts. Okay, this is this part, this is one part, this is another part, and both parts are similar. There is no difference in that. Both are similar, and these two buckets are equally separated or equally divided. A line. This is called splitter. This is called splitter. The splitter is used in the middle to divide these two buckets. Okay, and obviously what will be there here? So the jet will strikes at the splitting part, at the splitter point. Okay, and the splitter divides the jet into equal two halves, this side and this side, equal two parts, and at the outer of the edge of the part, the water will be come out from here. Okay, and the bucket shaped in such a way that here the bucket shaped in such a way that the jet will be deflected. The jet of water will be deflected here with an angle of 160 degree or 170 degree. What is the meaning of this? Now, when the water is coming out from this bucket, if you see the deflection, okay, that angle will be like, see, if it is come like this, then this angle will be 160 degree. Okay, that's why you want to say. So the deflection angle will be 160 or 170 degree. Okay, and these buckets, because we are discussing about the buckets. Okay, and runner part we have seen, runner and rotor part, which is nothing but a wheel, and where the buckets, number of buckets will be fixed on that. And the bucket is made of, okay, different materials like cast iron. Like cast iron is used, and we can say even cast bronze also. Even cast steel bronze. Cast steel bronze, or you can say the stainless steel also used. Okay, so this depends on conditions. This actually depends, like at what condition, at what head of the inlet of the turbine is used. If it is a little bit low head, so no need to go for that much. We can go for cast iron. If it is a high head is there, okay, high head will be there, means we need to go for some high strength material like stainless steel material. We need to consider in this. Okay, and as I told you, this is the shaft. Middle part of this shaft is this one, the shaft, and this will be connected to the generator. So I hope you understand here that this is the runner part. As I told you, this one is the shaft part that will be connected to this one, as I shown you here. So this will be connected to the generator. Okay, so this is all about the runner or rotor with buckets. Then the next one is casing. So casing and braking jet is simple. For that I have taken another one diagram. So first we'll see the third one is the casing part. Third one is casing. So casing, if you see, it is nothing but just a cover part. Okay, the function of this casing, if you see here, it is only to prevent the splashing. It is to only to prevent the splashing of water. Prevent splashing of water to outside, and also you can say to discharge the water. Here tail race is there. Okay, at this point tail race is there. After striking here, so it should not, the water should not go out. So it should be in the inside the casing, and it will be fall down to the tail race part. Okay, so also you can say this casing is used as a safeguard. It is to be used as a safeguard. Okay, any kind of accidents, to avoid any kind of accidental parts. Okay, and this casing is also made of like cast iron. This casing is made of cast iron or any kind of steel plates, fabricated steel plates. Okay, and yeah, so this is all about the casing part. And the last one is that is braking jet. The last one is braking jet. This is actually quite simple. There is that much function is not there for the braking jet. This is actually, if you see, when the nozzle is actually fully closed. Okay, like means when we are supposed to close the turbine, so what we will do, obviously with the help of this spear we will close this one. Okay, when it is the nozzle is closed, even the nozzle is closed, but the runner will be, okay, see this one we have closed, but what about this runner movement? So the runner will be continuously in the running mode or in the rotating mode. Okay, because the amount of the quantity of fluid or the velocity of jet which is striked here, very high velocity, obviously it will be started continuously rotating even it was stopped here. So due to why, because due to the inertia. Okay, this will be started running continuously running for the long time. So to stop this runner with a short period of time, to stop this runner, okay, with a short period of time, okay, a braking jet is used. A braking jet used. Okay, so this is nothing but also that the braking jet will be actually, it used to fit sometimes, like based on this there are different positions. So from here also they used to spray a water position, or sometimes they used to spray from here also like this. Okay, that means this will be opposite to the direction of runner. So the runner is moving in this direction, and the jet will be like, braking jet will be given a spray here from here, either from this side or from this side. So that is called braking jet. To stop the runner with a short period of time, or immediately, you can say that a jet is provided here. Okay, a small nozzle, you can say the small nozzle is fitted here. Okay, so that is to give a impact on this, so the runner will be started stopping the rotation. It stops the rotation. Now, so all these things what we have discussed about the working principle of this Pelton turbine, and now we'll see some basic things like application. What area or what is the basic application of this Pelton turbine? So while application, I can say the first one already I have shown you that diagram where it is applied for the hydroelectric power plant. So first application I can write hydroelectric power generation. This one I can write hydroelectric power generation. This is one application of this, because the same diagram I have shown you what we have discussed in our previous lecture. Now next one I can say that pumped storage plants. This is pumped storage plants. Along with that also, even many other applications also there, like irrigation department, irrigation, or we can say the water supply also we can use this. And in industrial also we can use this, in industry like paper industry or pulp industry we can use this one. So these are some basic applications. Even many more applications are there, just I've given a few example of that. And we'll see what are the basic advantages or what are the benefits of this or advantages from the Pelton wheel. So advantages, I can say immediately that it can be worked with a high head. It can be worked with high head, that what we have seen previously. Okay, and it is having higher efficiency. The efficiency is very high for this. Efficiency is near about actually like 80 to 90% efficiency used to there for this. Okay, and next one we can say this is the design is very simple. If you see the design is very simple. Simple concept is there. So the design we can say simple design. And the next one I can say durability of this product or durability of this turbine will be very high. So next one we can write the durability of this turbine is very good. And next one more point, let me tell you that it is very much easy to handle. Okay, or you can say that capable of handling large variation of flow. We can say it is capable of handling large variation of flow. Large variation of flow. So these are the some advantages of this Pelton turbine. Even obviously they will have some disadvantages about the turbine. Disadvantages of the Pelton turbine. Okay, and in the first point I can say here, this is as I written here high head. So here I can write this is not applicable. This is not applicable for low heads. So here it is advantages and here it is disadvantages. This is not applicable for low head. Okay, and similarly the second one I can write that yeah, here it is simple in design, but while construction of this power plant or this turbine, it is difficult. So here we can write complexity in construction. See, construction is different and design is here different. Simple in design, but while construction, this one somehow complex, difficulties there. Okay, similarly the cost of infrastructure. So high, we can write high cost of infrastructure. So these are the points will come under like disadvantages, and we can say in the inlet condition we required some high inlet pressure. This is not required that much, but okay, let's write like high inlet pressure is required. Okay, so these are the advantages, disadvantages, applications of Pelton wheel turbine. I hope you understand this working principle of the Pelton wheel turbine. Still, if you are having any kind of confusion, doubt regarding this, you can give a comment on the comment box. Thank you all.